21.4 day 2 is on the volumes of sphere. The content standard give an informal argument using Cavalier's principle for the formula for the volume of a sphere and other solid figures. Language objective. Explain to a partner how to apply the formula for the volume of a sphere. Alright, so let's review what we learned yesterday. So for the formula for the volume of a sphere is always 4/3 times pi times the radius cube. Okay, so then here for day 2 we're working with composite figure. Right? You can find the value of a composite figure using a perfect volume formula for different part of the figure. So example 2, find the volume of a composite figure round to nearest cubic centimeters. So for number 1, find the volume of a hemisphere. So hemisphere is half of the sphere, right? So then that means that this is 1/2 of 4/3 pi times the radius 5 to the third power. Well, 4 and 2 can cancel out, so this gives us 2/3 pi 5 to the third power. And from there, just use your calculator. Okay, so this gives us approximately 261.6, and this is centimeter cube. Right, so for number 2, to find the volume of a comb, so first, well, we need to find out what the height is. Right, so then this form a right triangle. So then we can find out the height by using the Pythagorean theorem. So this gives us 5 squared plus the height squared equal to 13 squared. Okay, so then take the square root of both sides. So the height is 12. Right? Okay, so when we know the height is 12, then we can solve for the volume. So then the volume, we see that is 1/3 pi times the radius, in this case is 5 squared, times 12. So this gives us approximately 314 centimeter cube. So then the composite figure, you would add those two. So we have 261.6 plus 314. And this is centimeter cube. Right, so let's go on to our next example. Okay, so for number 6, a composite figure is a cylinder with the hemisphere hole in the top. The bottom of the hemisphere is tangent to the base of the cylinder. Find the volume of the figure to the nearest 10. So for this one, what it is that first find the volume of a cylinder and minus the volume of a hemisphere. Right, so we're given that the diameter is 7 inches, so then the radius is 3.5 inches. Okay, and then we're also saying that here you say that hemisphere tangent to the base. That means that the radius touches the bottom of the cylinder, so then the radius is 3.5. So then we also know that the height of a cylinder is also 3.5. Right, so then we can find out the volume. The cylinder is pi times 3.5 squared times the height, in this case is also 3.5 minus 1/2 of 4 over 3 pi and 3.5 raised to the third power. So these cancel out. Well, when you look at this, this is 3.5 raised to the third power minus 2/3 pi 3.5 raised to the third power. Then they have the same exponent, so we can subtract those. So then remember that there's a 1 here that we don't write. So 1 minus 2/3 will give us 1/3 pi 3.5 to the third power. Okay, and then from there we can use our calculator. Okay, so I'll round this off to 8, and this is centimeter cube. I'm sorry, inches cube. Right, so let's go on to our next example. So here we have a composite function where we have a cylinder and 2 hemispheres on each side. So we can think of this as in terms of a cylinder plus a sphere. Right? So here we're given that the height of the cylinder is 5 and the radius is 2. So then for cylinder we can say this is pi times 2 squared times 5 and plus the hemisphere. And so we have 2 of those, so it becomes a sphere, so it would be 4 over 3 pi 2 to the third power. Right? And from there we can use our calculator to work this out. And they say that leave the answer in terms of pi. Right? So then this gives us 20 pi plus 8, so then it gives us 32 pi over 3. So we can change it into a common denominator, so this is 60 over 3 pi plus 32 pi over 3. So then the volume, when we add those, give us 92 pi over 3. Okay, so we can leave our answer in terms of our fraction as well. Okay, and then for number 10, we have our rectangular prism and a hemisphere on top. Right, so find the volume or composite figure, round the answer to the nearest tens. So think of it is that you have the rectangular prism plus a hemisphere. Okay, so then the volume of this composite figure is 376.52 centimeter cube. Okay, so can you guys try these 4 out, and as you go along, I'll give you the answers. Okay, so for number 6, you need to find out the height first. So let me work that out. Okay, I made a mistake here. So this should be a plus, right? We add them together, not take them out. So when we add those two, okay, so the volume for this one should be 828.96 centimeter cubed. And then for number 7, and then for number 8, so we're scooping out the hemispheres to find the volume of the comb, and then minus the volume of a hemisphere. and this is millimeter cube. Okay, so please check your answer for number 5 through number 8. Okay, so this is the summary for our module 21. Right, so to find the volume of the prism is the volume is equal to area at the base times the height, and the cylinder is the same thing. Okay, so for the volume, this would be length times width times height, or s squared times the height. And for a cylinder, the area at the base would be pi r squared times the height. Okay, so for the pyramid, it's always 1/3 times the area at the base times the height, and depending on whatever the base is. The cone is the same thing, but since the cone, the base will always be a circle, so we will 1/3 pi r squared times the height. Right? And for a sphere would be 4/3 pi times the radius to the third power. Okay, so let me add one more thing for a hemisphere. So then it would be 2/3 pi r to the third power. Okay, so then that's the end of our 21.4 day 2. You have your book set assignment, and you are to finish your HRW on 21.4, and then we'll be getting ready for our module test.